This is a little bit more complicated example of how you can use elimination to solve a problem, to solve a system. This one has 3 equations and 3 variables. So just to keep track, what I like to do is I like to label my equations because it kind of tends to get confusing. So this is A, this is B, and this is C. And right off the bat, what we're trying to do is we're trying to use these 3 equations and elimination to come up with a 2-equation system with 2 variables. And I look at these y values, and all of the coefficients will match up really well by just addition or subtraction. If they don't, we would multiply, but in this case, I could take equation A plus equation B. And if I did that, I would get 3x, the y's would cancel, plus 5z equals 18. So there's one equation, and the variables that I've got there are x and z. So then I can either take A and C and subtract them, or I could take B and C and add them. I like B plus C just because addition generally results in fewer mistakes. Oops, probably didn't want to do that. So if we add B plus C, we get 5x plus 3z equals 14. And I like to call this equation D and equation E. Now, if I wanted to have some things cancel, if I did 5 times equation D and 3 times equation D and then subtracting them, so let's see what that looks like. 5D would be 15x plus 25z equals 90, and then 3 times equation E. And maybe you can see why I'm labeling them all. It's kind of, there's a lot going on, and we want to kind of try to keep track of it. So we have 15x plus, let's try that again, 15x plus 9z equals 42. Our goal is to eliminate something. I've matched up the x's so that I can subtract. So I'm going to subtract the bottom equation. It gives me 16z equals, what is that, 54 or 48? 48. Divide by 16, divide by 16, and z equals 3. Now if I take 3 times d, I'll do it in a different color because I do want them to kind of look different here. 3 times d and 5 times e. To eliminate the z's, we can solve for x. So we're going to get 9x plus 15z equals 54. And 5 times e is 25x plus 15z equals, I believe it's 70. I'm going to subtract. I get negative 16x equals negative 16. Divide by negative 16, divide by negative 16, and x equals 1. Now I've got 2 of my values here. And technically, if I was using elimination, I'd have to go back and I'd have to solve. I'd have to get a different set of equations and then eliminate one of the other variables, like z or x, and then use elimination to find y. However, I think it's kind of appropriate at this point to look at any of the first 3 equations, like x plus y plus z. It's probably the most basic out of the 3. And if we plug in our 1, x is 1, and we plug in our 3, we can now use some simple algebra. So basically it's kind of a combination of substitution and elimination at this point. We can say, oh, y plus 4 equals 6, subtract 4, and y equals 2. So we have an ordered triple, x, y, z, of 1, 2, 3. And just like that. System of 3 equations in 3 variables using elimination.